To our video on curve sketching. We're going to start to use everything we know about derivatives to go ahead and be able to take a function like the one you see right here and sketch what it looks like. Now, we're not going to get the exact details on everything, but we're going to do the best that we can in terms of what is the function increasing, decreasing, where's there a max, what's the concavity, stuff like that. And you'll kind of see that we're going to kind of go through this list of things here. And this will help us find out what's going on with it. Okay, so the first one, looking at this function here, is we're going to look at the symmetry. Now for the symmetry, this just means you're going to plug in a negative x. Now when you plug in a negative x, if you get the same function, it's even. If you plug in a negative x and you get the complete opposite function, then it's actually going to be odd. So if I were to go through and plug in a negative x here, I would get negative, because again, all I'm going to do is pull out the negative. So the cubed root of the negative here, so we'll do this for symmetry. Get a little ahead of myself here. So if I do symmetry, if I plug in I'll call this f of x, just notationally so it's easier. If I plug in a negative x, I'm going to get a 6. The negative is going to come out. So we're going to get negative 6x to the 1/3. And then for this one, the negative is actually not going to come out because that fourth power is going to make it positive. So I'm going to get plus 3x to the 4/3. So this means that there is no symmetry. There's none, because I don't get the exact same function, or I don't get the complete opposite. What I mean by opposite is if this was a minus minus, that'd be the complete opposite. And again, the reason that this is a negative is because when you cube root a negative, you get a negative. And for this one, when you cube root a negative, you get a negative. But when you do a negative to the 4th power, it turns into a positive. So there is no symmetry. X and Y intercepts. This is something you've been doing for quite a while, since Algebra 1 really, is you need to plug in 0, comma y and x, comma 0. And this will give you your two intercepts. Okay, so just got to plug in a 0 for x. We'll give you the y-intercept. Plug in a 0 for y. They'll give you the x-intercept. So if I plug in a 0 for x, what's going to end up happening here, I'll just kind of alternate here a little bit. So x-intercept and y-intercept. We'll do x-intercept first. So this is when I plug in a 0 for y. So I'm going to get 0 equals 6x to the 1/3 plus 3x to the 4/3. And then this actually has a GCF of just x to the 1/3. So I'm going to get 0 equals x. Actually, it's got a 3 can come out as well. So 3x to the 1/3. I'm left with 2 plus x if I divide everything out. So again, if I divide in x to the 1/3 out, this gives me x to the 3/3, which is really turns into x. So I'm going to get x-intercepts of 0, and then x equals negative 2. And then for my y-intercept, I should get 0 here, because since an x-intercept is 0, then the y is going to be 0 as well. But if I plug in zeros, so I'm going to get 6 times 0 to the 1/3 plus 3 times 0 to the 4/3. That's going to give me a 0. Let's go on and talk about horizontal, vertical asymptotes. When we've done the definitions of those before, and those are when we find the limit as we go to infinity, or if we find the limit as x goes to some number and if it equals infinity. So there's actually going to be none. So for VA, HA, there are none. Well, real quick, if I do the limit as x approaches positive or negative infinity of this function, well, this is not going to equal a number. Okay, so that's why. So this is going to either equal positive or negative infinity, because nothing weird's going on with it. We don't have any restrictions with ln's. We don't have any restrictions with fraction, so there's going to be no horizontal, no vertical asymptote whatsoever. So This is telling us that there's no horizontal asymptote and no vertical asymptote. Again, there's no fractions in here to say it's not equal to 0. So we're good with that. Okay. Slant asymptotes, that's something that we really don't talk about too much in calculus, but it's a little bit extra. That's just when you have a fraction. We don't have that, so there is none. And if the fraction is higher by 1 power on top, that's going to give you a slant asymptote. Don't need to worry about that, though. So I'm going to kind of just cross that off. It's not our main concern right now. And let's go for derivatives, because the derivative stuff is really going to tell us what's going on with this curve. Okay, so let's go ahead and do that. So go ahead and find y prime. So y prime is going to give me 6 times 1/3, which is 2, x to the negative 2/3, plus 4 x to the 1/3. If you want to make this look nice and pretty, this is going to give me 2 over cubed root of x squared plus 4 cubed root of x. So now what we're going to do here is we are going to set this equal to 0. Let's go ahead and find our critical points. So set it equal to 0 and also see where the derivative is undefined, which will happen for this. So if we set this equal to 0, kind of the same thing that's going to happen that did up here is we're going to get a GCF. Oh, can't really see it. You're going to get a GCF here, just like you did here. And it's probably easier to work with this guy than my actual written out one. I will work with this one as well, do not worry. But I think it's easier to work with this one because this one has a GCF of 2x to the 1/3. Is that going to make our life easier if I do x to the 1/3? I think it's if I do 2/3. Yeah, negative 2/3. That's what I thought of. So I do x to the negative 2/3. That's going to leave me with 1 plus 2x. All right, so anytime you're dividing out here, okay, if you're dividing out a negative, you're just adding those numbers together. So that's why we're doing 2/3 plus 1/3, which is why I think that one's easier to do. You could plot a GCF of x to the 1/3, but it'll get a little bit messier. So you're going to get critical points here of 0, critical points here of negative 1/2. And then let's also see where the derivative is undefined. The derivative is undefined here when we set the bottom equal to 0. So it's going to be undefined at 0, which actually we already have taken care of here. So let's go ahead and make my sign chart. So we have a 0 and we have a negative 1/2. And we can go ahead and make our sign chart doing this. So we can plug in numbers that are less than that. So like plug in like a negative 1, for instance. Well, this will always be positive because of that squared. But if I plug in a negative 1/2 here, or sorry, negative 1 into here, I'm going to get a negative. If I plug in a negative 1/4, I'm going to go positive, positive. If I plug in a 1, I'm going to get positive, positive. So this is what my chart looks like. If I can just draw this, I'm going to go down, up, up, which means I'm going to have some type of extrema at negative 1/2. You could plug it in to see exactly what that would be, but I'm not going to worry about that too much because we're just sketching. I don't want to get too exact here. Now we're going to find the second derivative. And it's easier to do that off of this guy than that guy. So to do that, I'm going to get negative 4/3 x to the negative 5/3 plus 4 over 3 x to the negative 2/3. Okay, just double checking my work here, make sure I'm good. All right, so now I'm going to need to find the inflection point. So let's find the GCF here. GCF here, I think would be negative 4/3 is a good GCF for the numbers. And let's take out the lower amount here. So what's going to end up happening here is I'm going to get 1 minus, because it's negative, and this is going to give me a, if I'm dividing out that fraction, I'm actually going to have to add the positive because I'm subtracting it, right? So I'm going to be left with x. So Double checking my work here. Yep, x. So it's pretty easy. It's set equal to 0. So that part's going to give me a 0. That's going to give me a 1. So I'm going to make my sign chart here. Try to line it up with this one right above it as much as I can. So I have a 0 and then at 1. See what's going on here. So this all has to do with concavity here. So negative, anything that's negative. This looks like this is going to give me a negative. This is already, instead of that minus sign in front, if I plug in a -1, I'm going to get a negative here. Negative times negative is a positive. If I plug in a negative right here, I'm going to get another positive. So I'm going to get, yep, just double checking my work here. I'm going to get positive. Plug in a 1/2. I'm going to get a negative here. I'm going to get a negative here. Just double checking my work. No, I'm not. I'm going to get a positive here. So I'm going to go negative, positive, which is negative. Put a number that's bigger than 1, like 2. I'm going to go negative, positive. Nope, sorry. I can't do math. Negative, negative, which is going to be positive. All right, so I'm kind of going through this real quick because I don't want it to be a long video. But if you just plug in any number in here, like if I plug in a instance negative 1/2, that's going to give me a negative times negative, which is positive. If I plug in a positive 1/2, that's going to be a negative times a positive. If I plug in like a 2, that's going to give me a negative times negative. Okay, so that's where that sign chart comes from. So we do have inflection points here at 0 and 1. And now we just need to put this all together on a lovely little graph here. Now, I don't really know many points here, so x-wise, so I'm just going to make these tick marks. A couple things that are important that I do know are my intercepts. So I do know I have an intercept here. I do have an intercept. Where else? Oh, sorry. I have an intercept at -2. So there's only 2 times that it crosses. A couple important things here is at, I'm going to have some type of min. So I'm going to go down here decreasing and then increasing right there, while also having a positive concavity. And then at 0, something weird is going to happen at 0. And this is the last part I haven't talked about, is vertical tangent lines, cusp or corners. So cusp or corners are really going to only happen with mostly piecewise functions, but they could happen with cubed roots, stuff like that. We do have cubed roots being involved here. But this one is going to be a vertical tangent, because if you look at that right here, if you plug in a 0, you're going to get number over 0 on the derivative, which means that it's going to be a vertical tangent. So I'm going to have a vertical tangent here at 0, and then I'm just increasing as I go from there. So let's go ahead and draw this out. So I'm decreasing and also concave up. So I'm decreasing until I get to -1/2, and then I'm going to start increasing. Now this needs to be a vertical tangent. So if you notice, I'm trying to draw like the best vertical line I can right there. Okay, now I'm actually going to be concave down and increasing. I'm increasing the rest of the time. I'm concave down until I get to 1, and then at 1, I'm still increasing, but now I'm concave up. All right, so you will not get asked to sketch curves on the AP exam, but all of these little things can be hit, and that's why it is important. So you don't ever have to go from here, these sign charts, to here, but you will get asked about all these separate things. So this is really just a good day of review for the notes to go through some of these things, and really especially these last couple with the derivatives, increasing, decreasing, local extrema, stuff like that. Okay, so I know this one was kind of a little bit of a weird video because there's just so much little stuff going on. I did explain it kind of fast as well, so if you need to go through and watch the video again, be my guest. But that's it for curve sketching.